Okay, geometry class. This is section 9.5 involving tangent lines. We talk about tangent lines a lot in calculus class and maybe a little bit in trig, but tangent lines in geometry have to deal with circles and a line that's touching a circle, but it's only touching at exactly one point, okay? So a tangent line is a line that intersects a circle in exactly one point. That's a tangent line. And the place where it touches is called the point of tangency. I don't know if you can see that very well right here, but that's kind of what that is, okay? So if you think about, like, this is how I can relate this, okay? Let's say I have a bicycle, right? And here's my two bicycle tires. And what will happen, or like let's say these are two gears on a bicycle, okay? This gear is going to wrap around here, and it's going to wrap around here, okay? So the gear up here at the top, or the, whatever that thing is, that metal piece or whatever that goes around in a circle, the chain, there you go, the chain, I can't think. So here's my two gears, and I have the chain that goes around the bicycle, gears, and it kind of has like those little markings or whatever, and it like chinks around the two gears. That is this line that connects those two gears is a tangent line because he's touching here at only one point, and then he starts to wrap around the gear, okay? So that's kind of a demonstration of a point of tangency and what it kind of looks like in relationship to a circle, okay? So a common tangent, this is kind of like where the bicycle tire thing fits into play. So a common tangent is a line, a ray, or a segment that is tangent to two circles at the same time, okay? So I have two circles here, one's larger than the other, but they're saying that if I draw this line here, I have basically that line only touching each one of those circles at one point. It's touching, he's coming in, he's touching, he's like grazing it, touching at one point, and then he's kind of going off in the other direction. He's basically like sitting right on top of that circle, okay? I could also draw a tangent line going the other direction. I'm not very good at drawing here. Tangent line going the other direction where he's only touching right there, and he's only touching right here. So kind of the same thing, but in the other direction, okay? If I have two circles that are butt up against each other, like just right touching each other, I can draw a tangent line that's exactly straight up and down, and it's only touching each one of those circles once. Then example 1, they want us to do the same thing again, but they want us to draw our own, okay? So draw the common tangents. If no common tangents exist, state that no common tangents will exist, okay? I'll kind of talk about that here in a second, what no common tangents would look like, okay? So for this guy, I have two circles, but they're like kind of inside of each other. Like one of them, they're overlapping basically. So I want to draw a line so that it's only touching each one of those circles at one point, okay? So if I like draw a straight, like horizontal line up here, it's going to touch this circle at one point, but it's never going to touch this circle. So enemy's got to kind of be a slanted line a little bit, okay? And maybe if I slant him, trying to make him as straight as possible, okay? If I slant him like that and put a point here and a point here, okay, it's just coming in, it's just barely touching that guy, and veering off, okay? So that's one tangent line that I could draw, or a common tangent that I could draw, okay? I could also do one down here at the bottom. Oh, there's my kid that's crying. One down here at the bottom where he's touching here and here. And that's another common tangent. So I think those two are the only two that will exist like that, and those will give me two common tangents. Okay? What's the matter? Why did she bite you? Where did she bite you? On your tummy. On your tummy? Come take care of this. Malia bit her. Pretty hard. Right there. Okay. On part B, then we have, we're trying to find the common tangent, so the line that touches each one, and I'm going to maybe draw one here. So I have a point of tangency there, point of tangency there. I could also do one that crosses this direction. So it's going to look really similar to what this first one did up here. So touching there, and I was only touching at one point on each place, on each circle, and just like barely grazing off, okay? So that's what those will look like. Now, no common tangents, for example, that would be like a circle that is, these are concentric circles, if you remember, concentric circles. Concentric circles are ones that share the same center, so one's inside of the other. It's kind of like the ripple effect in a pond. There's no way I can draw a tangent line for both of them. Okay, if I draw a tangent line for like this one right here, maybe I draw a tangent line down there, right? There's no way I can get it to also be a tangent line for the other one. So that would be kind of a scenario where you would have no common tangents or no tangent lines for each one. Okay, all right, now there's two more concepts in this section. This first one says that a tangent line, so this is my tangent line down here, okay? He's tangent to the circle, he's only touching at one point and he's touching at T, okay? That's the point of tangency. Point of tangency. That's where he's touching the circle, okay? If it is a tangent line, it will always, always, always be perpendicular with the radius at that point. So basically, if I take the center S and I connect him to my point of tangency and create a radius, that will always be perpendicular to the tangent line at that point, okay? So that's just kind of the rule on how this works, okay? Now, they ask us a good question down here, example 2. Identify a tangent. They want to know if I have a tangent line here. So it says JL is a radius. This guy's a radius of circle J. Determine whether KL is a tangent line. So this is the line in question, okay? So I have my radius and I have my tangent line, and they're wanting to know, hey, is this a tangent line? And I can figure that out by determining if this is a 90-degree angle, okay? So then why did they put this 9 in here like that thing? That's confusing, right? What I can do with that is looking at this as a triangle. I can do the Pythagorean theorem to see if that is a right triangle, meaning this is a 90-degree angle. And if that's true, then this is definitely a tangent line, right? Okay. So the thing that they try to trick you here, though, is 9 is only going from here to here. Okay, so what would the whole entire length be from here to here? Okay, if I'm looking at this being 8, then that means this is also 8, because that's just another radius, right? Those are both the same length. So this is 8 and this is 8, meaning the whole length there is 17, okay? So I have a triangle with sides that are 8, 15, and 17, and I want to see if that makes this a 90-degree angle. Okay, so I test my Pythagorean theorem. The C, I have a squared plus b squared equals c squared. My c has to be the 17, and b, let's say, is 15, okay? So I have 8 squared, or 64, plus 225 equals 289, I think is what 17 squared is. Okay, so let's check that. 64 plus 225 is 289 equals 289. Okay, check. That means that this is a right triangle, which means that this is a 90-degree angle, which means that this line is tangent to that circle because he is making a 90-degree angle with the radius at the point of tangency, which is L. So yes, KL is a tangent line. Okay, all right. Next one, JH is tangent to circle G. So we know that this guy is tangent to my circle, which means that this has to be a 90-degree angle. Okay, we're not trying to prove that. We already know. They're saying JH is tangent to that circle. Okay, find the value of X. Oh my gosh, this one's a little bit more work. Okay, so again, we have a 90-degree angle, or a right triangle, okay, with a 90-degree angle in it, and I can use my Pythagorean theorem again. Okay, so I have one side that's X, I have one side that's 12, and then what will this side be? That side, since this is X and this is 8, it will be X plus 8 will be that side. Okay, so a little bit more work. I need a squared plus b squared equals c squared. Okay, so my first side, let's call x my a. So we'll call that guy x squared. Plus b has to be 12, so that'll be 12 squared, equals x plus 8 squared, which is going to look kind of funny like that. Okay, all right, now x plus 8 squared, this guy from algebra, is x plus 8 times x plus 8. You will have to FOIL, okay? All right, and when you FOIL, we'll take x times x, so that's x squared. X times 8 is 8x. I'll grab the yucky green color. Let's see if this one looks better. No, not really. The insides multiplied together is another 8x. Ugh, it's still really bad. Another 8x, and 8 times 8 is 64. Okay, so I've got that going on the one side. Over here, we've got x squared plus 144. We'll go ahead and multiply the 12 through. Okay? All right, so this actually comes out really, really nice because first thing I can do is 8x and 8x. I can add those two together and make 16x. But then also, I have an x squared here and an x squared here. Okay, and if I want to join them together, I can just subtract x squared from both sides. Okay, and really what's going to happen is both of them are going to cancel out. So that's kind of nice. I'm going to rewrite what I have now. 16x plus 64. Okay, and then let's subtract the 64 to get him with the 144. So I have 16x equals 144 minus 64 is 80, I think. And if I divide by 16, I think that is 5. X equals 5. 80 divided by 16 is 5. Okay? All right, so that one was a little bit more work, but they told us that this was a tangent line right here, which means he has to be at a 90-degree angle with that guy, which means that has to be a right triangle, so I can use the Pythagorean theorem. Okay? All right, last concept. This is my favorite one of the two, or of the whatever of all that we've done. Theorem 911. And this one is, I call this the ice cream cone theorem. Ice cream cone. This is my ice cream cone theorem, okay? So what this thing says is that if two angles, or if two segments are tangent to my circle, like this segment is tangent to my circle, and they're connecting at point B, then this length has to be the same length as this one, okay? Okay, those two have to be exactly the same length. And the reason for this is, okay, if I look at this as being an ice cream cone, okay, and I have basically my tangent lines that are connecting at this bottom part of my cone, okay, if these two are not the same length, my ice cream is going to fall off of my cone, right? Like if I have something here, let's say here's my tangent line, and let's say here's what I have going on here, okay, that ice cream is going to fall. That's a really bad drawing. My ice cream's going to fall off my cone, right? Like if they try to do, that's not going to work, right? If this is longer than this one, that's not going to work, okay? So my two sides have to be, if my two sides are making the two sides of the ice cream cone, they have to be exactly the same length. Otherwise my ice cream's going to fall off onto the cement and I'm going to be very sad, okay? So this one, A, B, and C, D are tangent to circle D. So these two are tangent lines, okay? That's all the information that I need to know. They're labeled as x plus 15. 2x minus 5. We know that these two have to be the same length, otherwise the ice cream cone is going to fall off. Okay, so I have x plus 15 has to be equal to 2x minus 5. And I just combine like terms. So I'm going to subtract the x, and I'm going to add the 5. I'm going to do those both at the same time. So I have 20 equals x. Done. Okay? All right, last thing, they have circumscribed polygons. So I have a circle that is circumscribed inside of each one of these figures. Okay, the first one is a triangle, and this is a quadrilateral, this is maybe a hexagon or something like that, okay? And so what I have going on here is, notice that each one of these lines that connects the outer edge of whatever shape is on the outside, these are all tangent lines, because it's touching that circle at just one point, okay? That circle is just fitting in there exactly perfectly, so it's only touching that circle at one point. Okay, this guy's touching that circle at one point. Touching that circle at one point. This side's touching that circle at one point, okay? Each one of those all the way around, okay, this figure 2, those are all tangent lines. When he is circumscribed inside of a figure, he's only touching at one point on every side, okay? This is an example of polygons that are not circumscribed. So this circle is not completely inside of this rectangle just because he's touching here, here, and here. So those three sides are good, but this side he's not touching at all. Okay, and this one's not touching any of those sides, so that's not going to work. Okay, so circumscribed, he has to touch each one of those sides at exactly one place. Okay, so a graphic designer is giving directions to create a larger version of a triangular logo shown. If ABC is circumscribed about circle G, so this outside triangle is circumscribed about the outside of G. They want to know what the perimeter of this is. So I want to know what this length is, this length is, this length is. I'm going to add them all together, okay? All right, so I really, when I'm looking at this, have just 3 different ice cream cones going on, okay? So let's look at this. Let's talk about this ice cream cone, okay? All right, so he's an upside down ice cream cone. If I flip him around this way, this is my ice cream cone, okay? All right, and they have this labeled. This guy is labeled as 8, so I know that this guy is also going to be 8 units long, okay? So that helps me determine those 2 things, okay? All right, now I have another ice cream cone here that's going on, okay? So I have that, okay? Let's see what those are labeled. This top guy right here is labeled as 7, okay? So that means this bottom guy here is labeled as 7, okay? So I have a 7 and a 7 and an 8 and an 8, okay? I'm going to start listing these here. 7, 7, 8, 8, because I don't have to do perimeter here. Now I just need to find out the last one. I'm going to do one more color here. Okay, I have this guy and I have this guy, but neither one of those are labeled, okay? I know they have to be the same length, each one of those, but none of them are labeled, but they do say that from here to here is 10, okay? And if I know that from here to here is 7, this guy has to be 3, right? So then this one's also 3, okay? So I've got a 7, a 7, an 8, an 8, and a 3, and a 3, and I want to add those all together and get the perimeter. Okay, so I'm going to do, this is 14, this is 16, this is 9. 14 and 16 make 30, and 30 plus 9 is 39, and let me get a pen that's not going to die on me, 39 feet, okay, and we're doing perimeter, which means it's not squared, it's just 39 feet all the way around there, okay? So just notice that each one of those is kind of an ice cream cone branched off of that circle, okay? So that's my favorite concept of the whole page, the ice cream cone thing, okay?